Hello, science fans. Today we are diving into the amazing world of artificial intelligence, or AI. The real scientific journey for AI kicked off around the middle of the 20th century. Pioneers started asking, can machines really think? This question sparked a revolution in computing. The year 1956 was a big one for AI. A famous workshop happened at Dartmouth College in America. This is where the term artificial intelligence was officially coined. The brightest scientists gathered, full of optimism. They believed they could make machines intelligent, perhaps even in just a few years. Their early ideas focused on making computers solve problems like humans do. They thought about logic, language, and learning. This was the very beginning of trying to codify intelligence, to break it down into steps a machine could follow. One of the very first big ideas in AI was what we call symbolic AI. This approach was all about representation. How do humans think? We use symbols. Words, numbers, and pictures are symbols. The early AI pioneers thought if we use symbols to reason and understand the world, maybe computers could do the same. So they started to build systems that manipulated symbols according to logical rules. Symbolic AI, sometimes called good old-fashioned AI or GOF AI, became the dominant way of thinking about AI for many years. It laid the groundwork for so much that came after. Understanding symbolic AI is like understanding the roots of a giant, fascinating tree. It helps us see where AI came from and how it has grown into what it is today. So what exactly is symbolic AI? Let's break it down. At its heart, symbolic AI is an approach to artificial intelligence where knowledge is represented using symbols. When you learn something, say a cat is a mammal, you are using symbols. Cat is a mammal. Symbolic AI tries to give computers the ability to work with these kinds of meaningful symbols. It is about making computers understand and manipulate information in a way that mirrors human logical thought. The core principle here is that intelligent behavior can be achieved through the manipulation of symbol structures. These structures represent different aspects of a problem or a domain of knowledge. For example, we could have a symbol for rain and another for umbrella. Then we could create a rule. If rain, then use umbrella. The computer doesn't feel the rain, of course, but it can process these symbols according to the rules we give it. This allows it to make intelligent decisions based on the information it has been programmed with. This approach is often described as top-down. Why top-down? Because human experts define the symbols and the rules. We provide the knowledge base and the reasoning mechanisms. The computer then uses this pre-programmed intelligence to solve problems. It is not figuring things out from scratch on its own from raw data, like some other types of AI. Instead, it is applying the wisdom we have encoded into its system. This makes it very deliberate and understandable. Let's delve a bit deeper into the thinking tools, the core principles that make symbolic AI tick. One of the most fundamental concepts is knowledge representation. This is all about how we store information in a way a computer can understand and use. It is not just about storing data, it is about storing it with meaning and relationships. Think of it like building a super detailed encyclopedia inside the computer's brain. Another key principle is logical inference. This is the process of deriving new information from existing information using rules of logic. Symbolic AI systems use formal logic, like propositional logic or predicate calculus, to perform these kinds of deductions. An inference engine is the part of the AI system that applies these logical rules to the knowledge base to answer questions or solve problems. Then we have rule-based systems, which are a very common type of symbolic AI. They work using a collection of if-then rules. Experts in a particular field, like doctors or engineers, help create these rules. Finally, search algorithms play a crucial role. These algorithms help the system find a path from a starting state to a goal state, following the rules and constraints of the problem. How does symbolic AI actually store all this wonderful knowledge we have been talking about? There are specific methods for representing information so the system can reason with it effectively. One classic way is using semantic networks. Imagine a web or a graph where concepts are nodes, like dots, and relationships between them are links, like lines. For instance, canary could be a node linked to bird with an is a relationship, and bird linked to has wings with a has part relationship. Another important method is frames. Frames are like templates or data structures that represent stereotype situations or objects. A frame for bird might have slots for color, size, diet, and habitat. Each slot can be filled with specific values, for example, color yellow for a canary, or even default values. Then there's logic programming, which uses formal logic itself as a way to represent knowledge and write programs. Languages like Prolog are famous examples. In Prolog, you define facts, for example, Socrates is a man, and rules, for example, all men are mortal. This is a very powerful way to build systems that can perform complex reasoning tasks. AI showdown symbolic logic meets machine learning. Now, let's talk about another big player in the AI world, machine learning, or ML. You've probably heard a lot about ML. It is the technology behind things like image recognition and personalized recommendations. So how does symbolic AI, our classic AI, compare to this newer star? They are quite different in their approach to becoming intelligent. Symbolic AI relies on humans explicitly programming knowledge and rules into the system. It is like giving the computer a detailed instruction manual for thinking. Machine learning, on the other hand, is all about learning from data. Instead of being explicitly programmed for a specific task, an ML system is fed vast amounts of data, and it learns to identify patterns and make predictions from that data. Think about teaching a computer to recognize pictures of cats. With ML, you would show it thousands of pictures labeled cat and thousands labeled not cat. The algorithm then learns the features that define a cat on its own. Symbolic AI uses deductive reasoning. It starts with general rules and applies them to specific situations to reach a conclusion. Machine learning often uses inductive reasoning. It looks at many specific examples and tries to infer a general rule or pattern. Symbolic AI excels when the rules of a domain are well understood and can be clearly articulated. Machine learning shines when there is lots of data, and the underlying patterns are too complex or subtle for humans to define explicitly. Why choose one? The strengths of symbolic reasoning. Symbolic AI, our trusty logic-based friend, has some really significant strengths. One of its biggest advantages is explainability, or transparency. Because symbolic AI systems operate based on explicit rules and knowledge, they can often explain why they made a particular decision. If an expert system diagnoses a fault in a machine, it can usually trace back the steps and show the specific rules that led to that conclusion. This is incredibly important in critical applications like medicine or finance, where you need to understand and trust the AI's reasoning. Another major strength is precision and reliability when dealing with well-defined problems. If the knowledge base is accurate and the rules are correctly formulated, symbolic AI can be extremely precise. It follows the logic impeccably. Symbolic AI systems can also be developed with relatively small amounts of data, provided you have the expertise to define the rules. Unlike many machine learning models that require enormous data sets for training, a symbolic AI system can be built if experts can articulate the knowledge of a domain. Furthermore, it is often easier to modify and update a symbolic AI system. If a rule needs to be changed or new knowledge needs to be added, a programmer can often go in and directly edit the knowledge base or the rule set. This ability to incrementally improve and maintain the system's intelligence is a very practical benefit. Symbolic AI in action real-world problem solvers. Where do we see symbolic AI in the real world? Early expert systems mimicked human decision-making. Mycin diagnosed infections and recommended treatments. Other systems configured computers, prospected minerals, and advised financially. Symbolic AI also played a role in early natural language processing. It focused on grammar, syntax, and semantics. Planning and scheduling are other areas where symbolic AI shines. It uses logical representations to find optimal sequences of operations. The flip side, challenges and hurdles for symbolic AI. Now, while symbolic AI is incredibly clever in many ways, it is not without its challenges. One major hurdle is something called brittleness. Symbolic systems are fantastic when dealing with situations covered by their pre-programmed rules and knowledge. However, they can struggle or break when faced with new, unforeseen situations that do not quite fit the existing rules. Another significant challenge is the knowledge acquisition bottleneck. Creating and maintaining the extensive knowledge bases and rule sets required by symbolic AI systems can be a huge amount of work. It often requires intensive input from human domain experts, and translating their expertise into formal rules can be difficult and time-consuming. Symbolic AI can also struggle with uncertainty and ambiguity. Human language, for instance, is full of ambiguous words and phrases. the real world often presents us with incomplete or fuzzy information. Traditional symbolic logic typically works best with clear, precise inputs and well-defined concepts. The future is bright and symbolic. What's next? So, what does the future hold for symbolic AI? Is it just a relic of AI's past? Absolutely not. While machine learning has grabbed headlines, symbolic AI is far from obsolete. Its most exciting days might still be ahead, especially when combined with other AI techniques. Symbolic AI offers unique strengths in our data-driven world. One promising direction is neurosymbolic AI. Combining neural networks with symbolic reasoning creates powerful, trustworthy AI. This hybrid approach could lead to more robust AI. The demand for explainable and trustworthy AI is growing. Symbolic methods provide transparency and step-by-step reasoning, essential for critical decisions in healthcare, finance, and autonomous driving. We need to trust AI systems. Symbolic AI is evolving and finding new relevance. Its principles of knowledge representation, logical reasoning, and explainability are timeless. The future of AI will be a rich tapestry with symbolic reasoning as a key part. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.